Okay, everyone can hear my voice? Okay, good. Then we start the session. Okay, mhm. So welcome you all to the live session of Physics of Renewable Energy Systems. This is live session 3 on 13th of August 2022. This course is taken up by Professor Amrish Chandra. He is professor in Department of Physics, IIT Kharagpur. And this live session is done by Rohit. I am from IIT Bombay. Okay. So in this session, we will discuss about some of the previous concepts, some previous assignment questions, and other relevant questions, and we will have a discussion with you guys. So be prepared for some questions. I would like to take some of your questions, and also if there are any questions in between the slides, you can ask them. Okay. Source. Okay, the first question is specific strength of the blades is important because see when we talk about some wind energy, then wind energy has to be taken from wind turbine or windmill. Okay, so there are two forms. One is through wind turbine and another is windmill. So what happens in wind turbine actually, we convert this wind energy directly to electricity, and in windmill what we do, we actually convert this wind energy to some mechanical energy like moving of fans or running of pumps. So these are some of the criteria which are used for harnessing wind energy. So when we talk of wind turbines, the blades which we use in wind turbines, so it has some specific strength. And what is this specific strength? This specific strength is nothing but the material strength divided by the density of the material. In simple terms, you must have heard that strength to weight ratio. That strength to weight ratio nothing but specific strength per unit mass. Okay. So this specific strength is important in blades. We will talk about this, but this is important because the first option is it reduces material degradation. Okay, second option is it reduces the gravity force. Third is optimal aerodynamics, and fourth is all of the above. So it has nothing to do with material degradation, specific strength. It actually reduces the gravity force because mass per the strength divided by mass. So a less mass material can give high strength. So that's why it has to do with the gravity force, because it reduces the m into g, this force actually. that is weight, it reduces the weight of the material. So the correct answer is B. And give optimal aerodynamics, it can't be a true option, partially true, give optimal aerodynamics, but aerodynamics doesn't have to are very much related with a specific strength of the blades. Aerodynamics has some other features like drag, or some other drag coefficient, coefficient of friction, and some other air velocity. These are some of the aerodynamics properties which are utilized. So specific strength in general doesn't have to do something with aerodynamics. So the correct option is option B. It reduces the gravity force. So specific strength is quite very important property if we see, very important. Why? Because see, if we take a rod, two different rods, this is heavier rod, this is lighter rod, okay, and this both has a strength of something 100 Newton per meter square. Let us say 100, yeah, 100 Newton per meter square. They can bear tensile strengths of something like. So simply if you go for heavier rod, then it will have a mass, and in wind turbines you have to move a mass of blade to generate electricity. So if it is lighter, then simple, it is a very good option to use lighter element in the wind turbines, because lighter element will move much more aerodynamically, much more better way, and also the total weight of the turbine will be reduced. So we don't have to erect a heavier pole, or we don't have to support the blades too much as that can be required with heavier blades. So that's why specific strength is a very important property here. Okay, and I just put a trick question for you. Do you know that carbon fiber, glass fiber, polymers, these are some of the topics which are very much in news in recent technological era. Carbon fibers have some carbon nanofibers in it on some metal matrix composites. Glass fiber have glass composites, some glass fiber like materials. Polymers, you know, chain of monomers that are embedded are called polymers. So these materials are actually very much discussed. Why they are discussed? Because they have a very high specific strength, very high, you can say. So that's why these materials are preferred. Now you got to know that a specific strength is a very good criteria when you are developing some product, or you are making a wind turbine or anything. A specific strength can be a very good option. So you just have to look the value of a specific strength. If it has a high strength to weight ratio, you are gonna select that material. So it can be a criteria for selection of material also. Let me see if anyone wants to join. It's behaving so oddly today. Don't know what has happened today. It's behaving so oddly. Okay, leave. Let's discuss first, then we will. Okay. The next is choose the correct steps which are arranged. Oh, it's not working today. We'll have to check something. Okay. So the next question is choose the correct steps which are arranged in order they occur. Okay. So during the synthesis of carbon fibers. Today actually I can't access the Microsoft Edge. I don't know. So if anybody has questions in between, he or she can write in the chat box. I can read the chat box. I can't. There's some issue with the this microphone, and it is actually pushing the Microsoft Edge to minimize. So if anybody has questions, he can write the chat box. I can read the chat box. Okay. So the question number 2 is choose the correct step which are arranged in order they occur during the synthesis of carbon fibers. So the options are, you can see options are basically treating the surface, stabilizing, carbonizing and sizing. So if we see the treating, let's learn the concept. What are treating the surface, stabilizing, carbonizing and sizing? So if we see the treating the surface is basically heat treatment. Heat treatment are basically some treatment done to the material, and it is basically done to enhance the properties of the material, like strength is enhanced if we do heat treatment. Malleability is drawing that metal or material into sheets. Ductility is basically drawing that material into wires, in form of wires. So if we say something is ductile, so what does that mean? Ductile is it can be drawn into wires. Corrosion resistance. Okay, corrosion, I think most of you know. What is carbonization? Carbonization is addition of carbon to make the metal harder. So if this is metal or material, what we do, we expose it to the carbon rich carbon atmosphere. Okay, and this carbon layer is actually embedded into it. So after having a carbon, what happens, it actually makes the material surface harder. So this is carbonization. Stabilizing basically relieving the material or metal from stresses. When we do heat treatment, then there are some stresses, or there can be some pre-stresses also due to the usage of material, due to its manufacturing, like forging, forming, etc. So stabilizing is basically stabilizing the material so that it can be used for some other processes also. If we don't do it, then it can bend, it can buckle. So these are some of the precautions we take. And sizing is basically providing finishing to the material so that it takes the proper size and proper dimensions actually. So if we see, first we have to stabilize. If we select any material for making carbon synthesis of carbon fibers, it has to be stabilized, it has to be relieved from stresses. Then the surface has to be hardened because it has to be used for wind turbines, so it has to be hardened. Then heat treatment is given, treating the surface so that some special properties can be enhanced, and then sizing is done. Okay, so the correct answer is D here. So if we want to do synthesis of carbon fibers, then first we do stabilizing, second is carbonizing, third is treating the surface, fourth is sizing. Okay. Okay, now let me check if I could answer. If I could, I don't know why I can't access. I can access this, I can access this, I can access. Let me open here. see if I can access it from here. Well, let's leave. I think we can't access here. Let's go to the slides. Okay, so yeah, we were at question 2. Question 3. A horizontal axis wind turbine with a 10-meter diameter rotor is 40% efficient in 10 meter per second wind at 1 atmosphere of pressure and 15 degrees Celsius temperature. 15 degrees Celsius is basically temperature of the ambient. It's saying 1 atmosphere pressure is for ambient. And how much power would it produce in those winds? Okay, density of air can be taken as 1.225 kg per meter cube. Okay, so I would like you all guys to solve this question. I will wait for 2 minutes, and if you guys, you can see the data. The diameter of rotor is 10 meter, efficiency is 40%, wind speed is 10 meter per second, and the ambient pressure is 1 atm and temperature is 15 degrees Celsius, and the density is 1.225. So this is the formula which you have to apply. Just apply this formula and tell me what's the answer, and try to write the answer in chat box, because I could not hear you any guys because of some microphone issue. I could read the chat box. In the meanwhile, I check what's the problem with microphone. Finally I could access it. Now I can hear you guys. Okay, so if anybody has solved this question, no answers. 19.2 Jayantan. Okay, Jayantan. Yeah, it's the correct answer. 19.2 is the correct answer. So it's a simple question. Let me solve you guys for you. We just have, this is the formula for power. So power is efficiency into 0.5 into rho is density, A is cross sectional area of wind turbine, and V is the velocity of wind. So we have efficiency equal to 40%, that is 0.4. Density is given, density of air 1.225. Cross sectional area is calculated pi d square upon 4. So cross sectional area is 78.5 meter square, and the velocity of wind is 10 meter per second. So we just put 0.4 into 0.5. 0.5 is just 1 by 2 into 1.225 into 78.5 into velocity cube, 10 meter per second cube. So if we multiply all these things, it comes out to be 19.2 kilowatt. Okay, it will come out to be 19 something, 19200 something. So this is in watt. You have to do it in kilowatts because the options are in kilowatt. So the correct option is option C. Okay, so we move to the next question. Any sir, can you explain how cross sectional area is calculated? Okay, Jantan, simple. If this is the wind turbines are like this. Okay, so this cross sectional area is basically how much area the wind will face. If wind turbine will move, how much area does this turbine blade sweep? This circle, whole circle, and the diameter is given 10 meter. Okay, 10 meter diameter rotor. So this whole circle area which the wind faces, if there is a wind here, there is a wind here, this is the cross sectional area. So for calculating this, simple, we calculate it through formula pi d square upon 4, the area of circle. Okay, you put the formula here, 3.5 into 10 square divided by 4, it's 78.5 meter square or something. Okay, so that's how it's calculated, and the correct answer is 19.2. Okay, the next question is, which type of material are useful for wind turbine blades? Quite good. So we were in slide 1, we were discussing about a specific strength. Now this, which type of material? So when we select a material, it has to be such that a very high specific strength is there. So if we see heavy iron is basically metal. Okay, aluminum is also a metal, non-ferrous metal. Non-ferrous means something which doesn't belong to the family of iron. Unmodified rubber, very low specific strength. Rubbers are elastic. So if you use something like elastic in the wind turbines, what will happen? The wind will blow through it and it will tilt there will be wobbling in the wind turbines, and the power production will also be low. Okay, wobbling is something moving in the wobble, what you can say, so like this. If this is a rod, you give it a vibration here, so what happens? This rod actually wobbles in between this is wobbling. Okay, so which type of material are useful for future wind turbines? So generally we were using some aluminum blades, aluminum composites blades were used. So earlier aluminum, because aluminum has a high specific strength compared to its weight, it has a very good strength. Okay, so earlier aluminum was used, stainless steel was also used, because stainless steel is resistant to corrosion, very high specific strength also. But nowadays cost is also an important factor, and strength. So what we see these days, that composites are taking replacing the metals in wind turbine. Now we understand that composite is the correct answer. Okay, but what are the composites? So composite is a material which is produced from two or more constituent material. Okay, and so you can say that, sir, what is difference between composite and alloy? Okay, so make sure composites are physical mixtures. Physically we mix two or more constituent materials and make composites. One is a matrix on which these materials were embedded. That's how composites are made. Okay, alloy is a chemical. This is totally a chemical. Two or more metals, we take two metals and mix them chemically. So a new metal is formed, that is alloy of these two. Like brass. Brass is alloy of copper and zinc, or brass. Bronze is copper of tin. So brass, bronze, these are alloys. Okay. And composites, carbon fiber composites, nano composites, there are hell lot of composites. There is so much of work going on composites, going on in these composites. And composites have lots of application. You will see, probably you can see most of the material which you use are composites only. They are also used in aeroplanes, they are also used in ships. So a lot of places you see composites application. Let me see if anyone wants to join. Okay, no one wants to join. So you got the difference between what are the composites. So what the concept we learn here, what are the composites. Second concept we learned, what are the alloys and what is the difference between alloys and composites. That is clear to you. And we are now focusing on more composites. Alloys are also used, but composites are actually much cheaper than alloys. We don't have to mix them. There is a simple matrix on which these materials were embedded. So they are actually much easier to fabricate also, and strength wise is also good. Composites have very high specific strength. Okay. Now the fifth question is, this is a very important question. When you learn about wind turbines, so there are hell lot of classification of wind turbines. You have to know these classification very pretty much going into these classifications. And why are these classifications of wind turbine? Okay, somebody wants to join. Let me see who wants to join. Why are these classifications? So these classifications are according to some working criteria, according to some how the wind flows to this turbine. So we will talk about it here only. And also because of some scientists who develop these turbines also, they are named after them, like Xavier Darius wind turbines or something. Okay. So in this question, the question is, which of the following can work with any direction of the wind turbine? So I put the figure here for both the wind turbines. The options are horizontal axis wind turbine. This is the horizontal axis wind turbine. So why this is called horizontal? This is the axis horizontal, and on this axis you see the blades are moved. Okay. So that's why it is called horizontal axis wind turbine. And vertical axis wind turbine, this is the vertical axis and these blades are moved like this. Okay. So these two pics I have put to make it clear what are the horizontal axis wind turbine, what are the vertical axis wind turbine. So which of the following can work with any direction of it? For these, if you see these wind turbines, only this direction of wind can come here, or this direction of wind can come here. If wind is blowing downward, this turbine won't work. Okay. But here the shape is such that any direction, even if tilted, it can't work. But even if tilted here, it will move the turbine blades. Okay. So that's why the answer is vertical axis wind turbine. The vertical axis wind turbine works with any type of wind turbine. Now if we see the horizontal axis wind turbine, so these are of two types. Okay. One is upwind turbines, upwind horizontal axis wind turbines. So what happens in the upwind horizontal axis wind turbine? The wind actually which comes faces the blades from front. Okay. It faces the blade from front. So that's why it is called upwind wind turbine. Okay. And another one is downwind wind turbine. Okay, yeah, downward wind turbine. Downward has wind facing from this direction. So rotor faces in this direction and wind is coming from backward. So this is downwind turbine. Vertical turbine axis wind turbine classification. If we see the vertical axis wind turbine, let me see, someone wants to join. Okay. So if we see the vertical axis wind turbine, the classifications are basically Darius, Savorius, and Gown Hall or something. Three types of classification. You can learn them from the slides. And which of these two do you think has a much better operation, much better power production? So if we see these two types of wind turbine, these turbines actually produce much higher power. Not power according to the but these are actually large turbines and could produce higher power in terms of power quantity. Okay, so that's why these are commercially more successful, more implementable. You see most of the wind turbines are like this only. But these wind turbines have very high noise, so they are noisier in operation. But this type of wind turbine very low noise. So that's why vertical axis wind turbine are actually getting more attention now, so that more power can be produced from here and much quieter operation. When you go to any wind farm, let me tell you, if you had any chance to visit a wind farm, you will see that these blades rotate and lot of noise is generated. So these wind farms, that's why these wind farms are located very far from city, some offshore areas or some outwards of the city, so that noise cannot disturb the people. Okay. Someone wants to join. Okay. Admit. So that's why these wind turbines are located very far from the city. These cannot be. Sir, can you explain why vertical? Yes, sure. So what happens here? If you see this, let me draw this wind turbine. This wind turbine actually looks like this. There is a shaft. This is called shaft, and these are the turbine blades. You will see the peak. Try to search this wind turbine. This is actually 2D image, so it's not clear here how this rotates. But these are like this. Some blades are like this. Okay, this is like this. And when the wind from any direction, even if it's horizontal, even if it's slant, so it actually make the blades rotate in this direction. Okay, and the blades are rotated through a vertical axis. You can see when these blades will be rotated, this will be rotated in accordance with a vertical axis. That's why it is vertical axis wind turbine. And here if you see, the blades are rotated like this. So according these blades are rotated in a plane of horizontal axis. So that's why it is horizontal axis wind turbine. Now the sixth question. So sixth question is basically a question related to fluid mechanics. Which of the following represent the continuity equation? When you see read about fluid mechanics, some of the equations, these continuity equations, momentum equations, some equations are very much used in fluid. Blades are like a sphere shape, so it can't operate wind from any direction. No, blades are not sphere shaped, Jantan. These blades are actually what I can say, some strip. If I could put, I will try to put a pic, a real pic or a video of wind turbine, vertical axis wind turbine. After this session is over, I will try to show you on YouTube. Okay, these are like strips. Okay, these are joined to the vertical axis, and these strips, when the wind strikes these strips, they actually move. So you can't say it's a strip; it's a blade of the vertical blade. Okay, and it's not spherical. Okay, sir, I understand. Okay, no problem. If you don't understand, I will try to show you also the working on the YouTube, so that you can get a proper view. In this slide, this is a 2D slide, so a proper view I can see that most of people, you can't imagine how this a 2D how this simple rotors can be rotated. Okay, so it's normal to visualize like this here, but when you see it in 3D, you will understand that there are some rotors here, and these rotors, when the wind strike, these rotors actually move. And I would suggest that you all guys can go to YouTube also, see the working of how the horizontal axis wind turbine works, how the vertical axis wind turbine works. So that's how when you see the videos, you will get a more better view of how this working of these wind turbines, and you can come with some good questions also, like, sir, I see this movement of this, so is this wind turbine can work with slant wind also, slant wind velocity also? So no, these type of wind turbine can work if there is a slant wind like this. So this wind turbine are actually fixed in this direction. In vertical direction it is fixed. It can only move in accordance to a horizontal axis. Otherwise what will happen? This wind turbine blades will wobble, and after wobbling there can be serious damage to the nacelle. This is called nacelle. This covering is called nacelle. Okay, so some serious damage to the nacelle also, and there are some gears also here, gears, bearings also, that can also be damaged. So it is fixed in one direction only, so that it can be rotated in only one direction. Okay. Now we were talking about continuity equation. So continuity equation are actually some basic equations of fluid mechanics, very much important. When you see the continuity equation, Euler equation, so these are some of the very much important equations of fluid mechanics. And what is continuity equation? In simple terms, I will try to make it simple. If there is a flow here, and this is a cross sectional area A1, let us see, take a value 1 meter square, and this is cross sectional area A2. Let us take the value of 2 meter square. Okay, so you see the cross sectional area is actually doubled here, and you take a initial velocity of 2 meter per second. So what will happen when this flow is going through this in time del t? Take del t equal to 1 second. So this will move to this much. Okay, but due to increase in cross sectional area, what will happen? This time del t, it will move only like this, only this portion. Okay, somebody wants to join. Let me see. So it can move only this much, and the amount of fluid which will move through this will be the same amount of fluid which will move through this in time 1 second. So you see the amount is actually getting constant. The amount of fluid moving here is equal to amount of moving here. So that's how this continuity equation is derived, that A1 velocity of fluid, A1 area cross sectional area at section 1 multiplied with velocity of fluid at section 1 will be equal to cross sectional area A2 into velocity of fluid U2. So what will happen if we increase the cross sectional area to 2 meter square? To maintain this amount of fluid in 1 second, it will half the fluid velocity. Okay, so earlier the fluid velocity was 2 meter per second, it will come out to be 1 meter per second. So you multiply into these two, 2 into 1 equal to 2, here also 2 into 1 equal to 2. So you see A1 into U1 equal to A2 into U2. So the correct option is option A, A1 into U1 equal to A2 into U2, and A represents the cross sectional area and U represents the velocity of fluid. Okay. Now the other questions, other options, A dot into U1, A dot into U2. What are these dot? These, when we put a dot here, it is a flow rate. It represents a rate. Okay. So when we put a dot here, it will represent rate of change of area. So continuity equation is not related with rate of change of area. We put a dot here, rate of change of velocity. What is rate of change of velocity? Acceleration. Okay, so this is also wrong, this is also wrong. It has nothing to do with acceleration, it has to do with area and to velocity. And simple using continuity equation, we derive the Euler equation also, Euler and Bernoulli equation. So first which equation come? Bernoulli equation. And Euler equation is the extension of Bernoulli equation. And these two equations are actually derived from continuity equation only. You will see in the slides which the professor has taught. He has actually very beautifully explained how these equations were derived. So you can go through them and you can also understand how these equations were derived. These are some of the basic equations: Bernoulli equation, Euler equation, Navier-Stokes equation. Okay. Then you will go for laminar and turbulent flow. So how these are distinguished? Through Reynolds number. Okay. If Reynolds number is greater than a specific amount, then it is turbulent flow. If Reynolds number is less than a specific amount, it is laminar flow. And there is also flow in between, where there is a transition between laminar and turbulent flow. Let me also explain what are laminar and turbulent flow if this topic has come, so that you guys have clear idea. So laminar flow are actually flow in lines. You see a very calm flow where the particle, if this is a fluid particle, so this fluid particle will move according to line. If you place a cylinder here or something, it will just bend and these lines will come closer. But when this again the space is there, these will separate again and the flow will be like this. So this is a laminar flow. But in turbulent flow, what happens? It flow in some zigzag patterns like this. So what happens in zigzag pattern? The energy lost. These particles actually strike each other and the energy lost. So that's why we prefer laminar flow, and to if we want to extract energy. So flow, for wind turbine, wind or air is a fluid. So when this, what we prefer for wind turbine, we prefer that it flows in the laminar flow, so that most of the energy can be extracted from it. If the air flows in turbulent flow, then it will strike, the particles of air will strike each other and the energy will be diminished. Okay. Now the question number 7. Role of nacelle is to: first is generate power, second is store wind energy, third is protect the engine, fourth is protect the turbine blades. This part is called nacelle. Okay, in wind turbine, this I have put the whole pic here for wind turbine, so that you people can actually visualize what are the important components of wind turbine. So this is the rotor. Rotor consists of hub. This is hub, and these are called blades. Okay, so generally we have 3 blades, but there are also 4 blade wind turbine. It depends on the commercial operation and how much power we need to generate. So that's how the blades are selected and optimized actually. So this, the covering consisting of generator, the drivetrain and other controls is nacelle. So what is the role of nacelle? It actually protects the generator and other mechanism here present here. So the correct option is protect the engine. Okay, not only engine, generator. Engine here is actually it is referring to generator. Generator plus drive trains are there, gear mechanism are there actually. A big gear is there, a small gear is there, so that this gear is actually connected to a motor shaft, a generator shaft, and that's how the power is produced and transferred to the transformer here. There is a transformer here actually, and through this the power goes to the grid or home, anything. Okay, so this is the, and this is your system. What is the role of your system? It actually moves the nacelle in this vertical direction. Okay, so it actually not in vertical direction, I think it moves in vertical direction, according to vertical direction. It actually rotates the whole setup so that the turbine blades actually faces the wind. So what happens, this, if this is the turbine blades, so wind is like coming from this direction. So what is the role of this yaw system? This actually rotates the whole thing so that wind blades are like this, and the winds are now perpendicular to blades here. So that is the main role of yaw system here. Okay, and there are some other mechanism also which are not depicted here. So this, let me draw the whole thing. This is hub, this is blade, there is a shaft, there is a big gear, this gear is connected to small gear. So why it is connected to a small gear, big gear to a small gear? So you see that when we drive a small gear through big gear, so due to the gear ratio is basically the number of gears in 1 to number of gears in 2. So if we have a high gear ratio, then this will move faster to make up to the speed of this much, because this is small, so it will move faster. A faster rotation will actually move through a generator plates. This generator has some electromagnetic coil in there. Due to the movement of plates, a current is induced due to Faraday's law. This current is actually taken out through these cables which are into the tower, which passes through the tower. There is a transformer here. This transformer actually transforms the voltage which is produced through it, and a lot of wind turbines are actually placed one by one. So these are actually connected, and the whole power is then put to the subsystem here. This subsystem actually feeds it to the grid, and from this grid we use it in our homes. Or sometimes a single wind turbine is there, then this can be directly fed to, from transformer it can directly be fed to homes. So if it is single wind turbine and used to run homes, it can be called decentralized. If there are a lot of wind turbines in row and all of them generate power, and these power are used to fed in grid, then these are called centralized wind power production. Okay, so you got to know decentralized and centralized wind power production. Now the question 8. Question 8 is basically limitation of wind based energy units are. So limitation of wind based energy units. These units should not be there. Limitation of wind based energy are. So what are the limitation of wind energy? If we are thinking of getting a wind energy, getting electricity from wind, so what can be main limitation actually? So if we see the wind turbine, okay, the first thing is that wind doesn't always blow. What is the saying about renewable? The sun doesn't always shine, the wind doesn't always blow. That is, these are intermittent in nature, not always. You can't expect wind to blow 24 hours. Okay, so these are actually not very much consistent. The resource is not consistent. What is the resource here? The wind is not always consistent. So that's why the first option is correct. The wind is inconsistent or intermittent in nature. Okay, second, can harm local birds. So these wind turbines are actually situated on a tower, these rotor blades. And what happens, some birds are there, these birds can strike these wind turbines, like these wind turbines obstruct the pathways of birds, the fly pathway of these birds. So this is also a very big problem. We don't want our birds population to go down. Why? Because these birds are actually part of food chain, they eat the insects, and we don't want that these birds should not the population of birds should go down. Also there are some ecological benefits also with birds, so you can't actually harm ecology for technology. This can be a line, you can't harm your ecology for pushing some technology. So that's why it is also a big problem, can harm local birds, can be expensive. Wind turbines are really expensive, they are very expensive. The land cost, the installation cost, the material cost, the optimization cost, the operation and maintenance cost, the engineer and skilled labor cost which will go into installation. So they are really expensive for setup. So yeah, this can be expensive. Lots of research are going on to make materials, to select those materials which are less expensive. So like composites are actually cheaper than metals, especially aluminum is very expensive. Okay. Second is noise pollution. I told you in slide 6 or 7, I told you about the noise pollution, how much noise this wind turbine makes. These wind turbines are actually very much noisier. When you go near a wind farm, you will see that the noise generated by wind turbine is actually comparable to the noise generated by an aeroplane. It is most of people who reside in nearby aeroplanes or aerodrome can relate with me, or someone who has house near wind turbine, which is not so specific. I don't know if anyone of you has your house nearby wind turbine, or if you have a chance to visit these wind turbines, try to go there, you see the operation, you will feel the noise. A lot of noise is generated by wind turbines. Okay. So we see that all of the options are actually correct for limitation of wind based energy. So the correct answer is all of the above. Now another question is, what is the difference between steady flow and uniform flow? This is the question, conceptual question which I had taken from slides, and I want you to understand this concept very much, because these concepts are actually very much utilized in production of energy from wind. Okay. So when we talk about steady flow is basically when fluid is said to be in steady flow when its property doesn't change with time. So if there are any properties which are represented by P, and dP by dt is always constant, doesn't change with time, then this flow can be said to be steady flow. What can be the properties of fluid? Like velocity, like density, some other properties are also compressibility. Okay. So these properties, if they are consistent with time, they doesn't change with time, so this can be told to be a steady flow. And in uniform flow, what happens? The property doesn't change with space. What we mean by space? Space is distance only. Okay. So if a fluid is flowing, let's see, water is flowing. If this water has velocity air 1 meter per second at this point A, and after some distance at point B, we measure the velocity and it is found to be 1 meter per second. So what do we saw here? We saw that property, that is velocity of water, doesn't change at A and B. So this flow can be called as uniform flow. Why uniform flow? Because it doesn't change with distance or space. And and let us suppose a point C here. Water is flowing at 1 meter per second. Okay, we measure 12 o'clock, we measure the velocity is 1 meter per second, and after 2 minutes at 12:02 we again measure the velocity, again it is found 1 meter per second. So what do we see here? We see that velocity is not changing with time, so this flow can be called as steady flow. There are other concepts here: path line, streamline, trajectory. So I would suggest that you go through these concepts, are very beautifully explained in the slides. I will suggest all of you to go through these concepts, because these concepts are actually very much utilized for determining the directions of flow and also the velocity of flow, acceleration of flow. Okay, so that's how the today's session is over. And if there are any queries, I think I can't hear you guys because of some microphone issue here. So if there are any queries, you can always write it in the discussion forum of the NPTEL course. And also if there are any queries, you can write it now in the chat box. I am reading the chat box. Like Jantan has asked some very good questions, so you guys can ask questions, and this is the question hour. If anybody has any question related to slides, let me go through slide 1. So if you guys have any question, so let me put a recap. Someone has many of you have joined late, so you will get to know these concepts again. So as we talked about specific strength is basically strength to weight ratio. Okay, so we always prefer some material which has a very good specific strength, because for a very less weight it can gives a very high strength. So these type of materials are preferred, and it actually reduces the gravity force. So the correct answer is B. And these materials, carbon fiber, glass fiber, polymers, have very high specific strength. So most of the application which we see for carbon fiber, glass fiber, polymers, these are mostly because they have very high specific strength. Now we discussed about heat treatment. Heat treatment is basically treatment given to the surface of material, and it enhances property like strength, malleability, ductility. Carbonization is addition of carbon to make material harder. Stabilizing, relieving stress, and sizing is actually providing finishes. So this is the actually flow. If we want to synthesis carbon fibers, we then solved a numerical here. We utilize a 10-meter rotor which is 40% efficient and has a wind velocity of 10 meter per second, and the ambient pressure and temperature are 1 atm and 15 degrees Celsius. The density of air is 1.225 kg per meter. So we simply just have to put these values in this formula. This is empirical correlation between power and these values. We just put the values and calculate that it is equal to 19.2 kilowatt. So you can see a 10-meter diameter rotor with a wind velocity of 10 meter per second can produce 19.2 kilowatt of energy. And how much is the room heater? Room heater is 2 kilowatts. So you can see a wind turbine can easily power your home. A 10-meter diameter rotor with 10 meter per second flow of wind and 40% efficiency can easily power your home. Then the next thing we discussed about the material which is used for future wind turbine blades. We see that composites are now a craze for using material for so much of products, and composites are actually made from 2 or more material constituent materials, and these are actually very much utilized for wind turbine blades also. In question 5, we saw the classification of horizontal axis wind turbine, vertical axis wind turbine, and got to know that vertical axis wind turbine can actually work with any type of wind, any direction of wind. Like wind is coming from this direction, wind is coming from this direction, any direction of wind, it can work. We then learned the continuity equation. In continuity equation, we got to know that area, cross sectional area multiplied with velocity is actually remains constant for the whole fluid flow. So this is the continuity equation. Using this equation, Bernoulli, Euler and Euler are actually derived using continuity equation. Role of nacelle, we got to know that nacelle is basically a covering to protect the generator, motor and other gear train drive. Then we learnt about some limitation of wind based energy. So the limitation, we see that wind is intermittent in nature. It can harm, wind turbine can harm local birds. They are actually expensive and causes noise pollution also. So all of these options are correct. In question 9, we see that what's the difference between steady flow and uniform flow. We got to know that if any properties are actually constant with time, so it is steady flow. If it is constant with distance or space, then it is uniform flow. Okay, so that's how the session for today is complete. So if you guys have any question, you are always welcome to ask me in the mail, and you are encouraged to ask these questions in the discussion forum actually, so that if these questions are there, I can answer, and other people can also benefit from these questions. So it's better you can ask these questions in discussion forum. Okay, and if there are no questions, no doubts, then we end the session here, and we will meet again on next Saturday from 7 to 8. Okay, best of luck, best wishes for you all guys.